All right, so this is sections 5.2 and 5.5 in your textbook. Okay, and this is really going over the rules of simplifying exponential expressions. Okay, exponential expressions are just expressions with exponents in them. Okay, so um, we'll be going over all of that. We've gone over the product rule already. Okay, there are 6 rules that we're going to use. Okay, the product rule we've already gone over. In the last one, we talked about multiplying polynomials because when we multiply like bases, we add our exponents, right? So if we had examples like this, multiply your numbers -2 and 3, add your exponents, right? X cubed, y to the 9th, okay? So we can color code those in a little bit, right? Gone over that. Quotient rule. This is when we divide like bases. Divide like bases, we subtract our exponents, okay? Divide, we subtract. Multiplying, we add. Divide, we subtract. So for this one, again, here we're just going to divide our numbers just like we multiplied our regular numbers. Those are not exponents, right? We're only subtracting exponents, and we are adding exponents when we multiply. They're not exponents, you just do the operation. So 36 divided by 6 is 6. Then we say x to the 10th, x to the 4th. Okay. So 10 minus 4 is 6. Then we say for y, 5 and 1. Okay, so y, 5 minus 1 is 4. And that's it. Quotient rule, product rule, adding when you multiply, subtracting when you divide. All right. Zero exponent rule. Zero exponent rule. Anything raised to the 0 power is equal to 1. Okay. Anything raised to the 0 power is equal to 1. Okay. So for this one, we just have 1, right? These two look the same, but one of them has parentheses, one of them does not. Okay. This is saying -3 to the 0 power. Anything raised to the 0 power is 1. So it's 1. This one doesn't have parentheses. Okay, so we're only raising really the 3. Okay, so this one's actually going to be -1. Okay, those parentheses help us out a lot, right? Anything raised to the 0 power is equal to 1. That's the main thing. Okay, then we have a negative exponent rule. Okay, negative exponents are not good. Okay, we don't like them. So anytime we have a negative exponent, the way that we make it positive is we move it. Okay, so if we have a negative exponent in the numerator, we're just going to take that negative exponent and its base and move it down to the denominator. If it's in the denominator, we're going to move it up to the numerator. Okay, so wherever it is, we're just going to move it and it becomes positive. Okay, so 6 to the -2nd power is obviously in the numerator, right? It would be over 1. So we're going to move it to the denominator and make it positive. Okay, well, 6 squared, we know what that is. It's 36. And we're left with 1 over 36. Okay. It was in the numerator. We moved it to the denominator. And it made it positive. Okay. For this one, What is negative? The x, right? So we only move the x. The y, there's nothing wrong with it, right? Y to the 6, there's nothing wrong with it. The only thing that was negative was our x, so we move it to the bottom and make it positive. Okay? Sometimes you guys can really struggle with this, okay? But you just need to remember, what is negative? And I'm just gonna move that part, okay? Right, so this note here says, make sure to never leave a negative exponent in your final answer, okay? So let's say maybe you do the product rule, like we're about to do, the product or the power rule, you say, and you end up at the end with a negative exponent. We'll just move it at the end, okay? So here's another rule. It's called the power rule. And this is when, look at the way these look. You have, I like to say, I'm gonna write this down. Something raised to an exponent, all raised to an exponent. Okay, look what I mean. Something raised to an exponent, all raised to an exponent. Okay, when that happens, we multiply our exponents. Okay, you will always have something on the outside with these. You're going to have parentheses, and you're going to have a power on the very outside. Okay, that's what that means. Okay, when you do that, you're going to take, so in this example, you're going to take 2 and raise it with all these. Okay, so this is what I mean. 8 squared, x cubed squared, y to the negative 5th squared. Okay, I know that 5 is negative, but I'm not going to deal with it until the very end. Okay, I'm just going to do my rule. All right, the power rule says that you multiply your exponents when you have stuff like this. All right, so 8 squared is just 64. And then 3 times 2, that gives us 6. And then negative 5 times 2 gives us negative 10. Okay, so here we are right now. And if I just gave you this, you would say, uh-oh, this is a no-no. This needs to move to the bottom. Everything else is fine. 64, there's nothing wrong with it. X to the 6th, there's nothing wrong with it. The only thing that needed to move was y to the 10th. Okay, so let's just look at what we just did. We recognize that it was the power rule because we have something raised to an exponent, raised to an exponent. Okay, again, it's always going to look like that. You're going to have something on the very outside that you need to take to the inside. So I raised each of these inside to 2. And then I did the product rule. Okay, so that was the power rule. This is quotient to power rule. Quotient to power rule. So what I have going on inside my parentheses is the quotient, right? That means division, all raised to a power. Okay, all that means is I'm going to take each thing inside my parentheses and raise it to n. Okay, so look at this one. You have some negatives going around, but that's okay. Don't mess with it until the end. You have the quotient raised to a power. So you need to take x to the 5th and raise it to the negative 3rd. Then you need to take y squared and raise it to the negative 3rd. Now do the power rule. you multiply your exponents, right? Anytime you have something that looks like this, you multiply. My pen is a little too thick. There we go. Y to the -6. Now, you have negatives in both places. This needs to go to the bottom. This needs to go to the top, correct? That would fix both of our issues with our negatives, okay? So really, if they're both negative, you're just going to switch them. So we need y to the 6th, x to the 15th. Okay. That was quotient to power. So really the most difficult part of this is being able to recognize what rule to use when, okay? But it helps you, and you'll notice the way that I speak about these problems is the same pretty much every single time. I look at the problem and I say, okay, let me identify what I need to do. And then, so identify what rule I need to use and then use it. Okay. So some guidelines here to simplify exponential. So we're going to try and simplify inside the parentheses if we can, move any negative exponents if we can, put any common bases together. So that may look like product rule, product to power, something like that. And make sure your answer contains no negative exponents. All right. So let's look at this example. Obviously, it has something to do with the quotient, right? Because we're dividing. This is just a normal quotient rule. 10 divided by -2 is -5. These are like bases, right? So we can say, you always say numerator minus denominator. So we would say 5 minus 6, and that's -1, which is a no-no. So we need to move it to the bottom. Okay, here's how here's an easier way that I like to do it. Okay, when it comes to the negative exponent stuff, we are subtracting, right? Because we're doing the quotient rule here. All right, so I like to subtract wherever the bigger number is. Okay, so if I were doing this, 10 divided by -2 is still -5. And I'm cool with that being negative. Okay, I'm fine because that's not an exponent, that's just a number. So that can stay where it's at. Okay, now I'm going to say 6 minus 5, and I'm going to put the x and the exponent wherever the bigger number is. Okay, so 6 minus 5 is 1, but I'm going to put it in the denominator because that's where I started from. So I would put x in the bottom. So you get the same thing, you just skip this step. Okay. And we'll get some more practice with that. And that was just straight quotient rule. Okay, I'll write the rules if it helps you identify them. Okay, let's look at this one. So we have this being multiplied towards this. Look at this second one though. What's that have? Exponent on the outside, right? So looking here, right? We need to deal with this 3. So you have 4a squared, and you have something raised to a power, raised to a power. So we need to take this 3 to everything inside. So we need to have -2 cubed times a to the 4th cubed. Okay, I'm just bringing this 4a squared along for the ride for a little bit. Now I have, I want that all to be one thing. Okay, so -2 cubed is -8. And then we're multiplying our exponents here, right? That's the product, that's the, sorry, power rule. So a to the 12th. Looking here, this is just a power rule, right? You have something times something. There's nothing on the outside here. There's no power there. So 4 times -8 is -32. And then we multiply our exponents when we add our, we add our exponents when we multiply. Got my words mixed up, right? We add our exponents whenever we multiply. So we have a to the 14th. Okay, so we did here to here was power rule. And then here was product rule. Okay, so it's important for you to take these step by step, okay? What about this one? This one has a lot going on, right? First thing you should notice, division, quotient, to power. So, stuff here. That 3 needs to go to the top and the bottom. Okay. Now, look individually here and here. Power rule. You need to take 3 to each. Okay. So we need to say 30, -30 cubed, a to the 14th cubed, b to the 8th cubed. Same thing on the bottom. 10 cubed, a to the 17th cubed, b to the -2nd cubed. Okay. Now we just have a bunch of product rules. Okay, 30 cubed is a very large number. It's like 27,000. That's very, very large. Okay, then we'll say 14 times 3. So we get a to the 42nd, b to the 24th, right? Then you have 10 cubed, which is 1,000. And then 17 times 3 gives you 51. And then b to the -6th, right? So 27,000 divided by 1,000 just gives you 27. So that was super large, but now it's not anymore, right? Okay, now look at your A's. So we've dealt with these. We dealt with that. Look at your A's. Where's your bigger number? It's in the bottom. So you know A is going to be in the bottom. And you have 51 minus 42, that's 9. So a to the 9th in the bottom. Okay, now watch what we have to do with your B's. 24 minus -6. Okay, 24 minus -6, which means we're doing 24 plus 6, right? Which is 30. So we have b to the 30th power. Okay. I'm gonna give you a second to look at that one. That one was pretty tough, but we just took it step by step with each of our rules, okay? We took the 3 to the numerator and denominator. Then we took it to each piece in the numerator and denominator and did our power rules and then simplified. Okay. Let's look at this one. We have a bunch of negatives running around. It's kind of hard to even look at, right? So let's start off with let me try to highlight for you. Maybe you can underline, that may help a little bit. Negative 24 divided by 8 is 3, right? Let me try to color code it. So 24 divided by 8, that's 3. A to the second, a to the -5th. Okay, so we're saying 2 minus -5, which is 2 plus 5, which is 7, right? So we have a to the 7th. Now, look at your b's. We have -2 minus -1, which gives us -2 plus 1, which is still -1, right? So we have b to the -1st power. If you realize that and go ahead put it in the bottom, that's fine too. Okay, you can go ahead and put it in the bottom, or we can do it in one more step, like I'm going to do in a second. For C, in purple, you have 8 minus -3, which is 8 plus 3, which is 11. So we're good. That one stays in the top. The only thing that needs to move is your B. Right? Okay. And that is using our rules. Okay, so they can get kind of messy. All of these examples were pretty difficult, especially the last two. But the main thing is to take it step by step and say, okay, what are we even trying to do? What are our rules? How do we apply them? Okay.